Hello, I'm Ketan Goel, pursuing MTech from VIT University, Chennai. I'm going to tell you about types and methods of connections. So, connection are structural elements used for joining different members of structural steel frameworks. Connection basically we see for steel structures. So, structure is an assemblage of different members such as beams and columns, which are connected to each other, usually at the member and fasteners, so that it shows a single composite unit. Many configurations are used for force transfer in connections. The configuration depends upon the type of connection, connecting elements, nature and magnitude of force, and available equipment, fabrication and erection consideration, and cost, etc. So the different types of connection depend upon the different sections used for connections, and then availability and nature and magnitude of the forces. So we have different types of components in connection. So connection we can done using bolts, welds and rivets. Rivets nowadays usually we are not using it. So nowadays we are using bolts and welds. Then we'll use connecting plates in it and connecting some different connecting angles in it. So first we'll see bolted connections. What are bolted connections? So as we all know, bolted connection means we'll use bolt to connect two different structural members. So fastened together primarily by bolts. Then bolts may be loaded in tension, shear, or both in tension and shear. Threads of bolts under shear force. So if it is excluded, then it increases the strength, and if it is included, then it decreases the strength. If the threads that we have on bolt, if we are excluding it in the connection, then it increases the strength, and if we are including it in the connection, then it will decrease the strength. Then we have different types of bolts. So first one is bearing type of bolt. Second one is high strength friction grip bolt. The most common type is bearing bolt. Whatever we see in the day-to-day life are the bearing bolts, or often it is referred as black bolts. So they are ordinary, unfinished, rough or common bolts, which are very cheap, least expensive we can say. Then these are primarily for light structure under static load, such as small trusses or purlins. So we'll use to connect members for truss or purlins by using these bolts. So we'll choose this type of bolts if we have very less loads applying on our structures. Then we have turn bolts. So these are similar to unfinished bolts, and these have hexagonal shank, again primarily for light structures under static load, such as small trusses and purlins, like we seen for blackboards. Then if we go for some expensive bolts, then we'll use it for we will limitedly use it for structural with no slipping connections. Then next we have rib bolts. So these may be hexagonal or round. Usually we have round heads like rivets, raised rib parallel to the shank. Then actual diameter is slightly larger than the hole. Uh, Tightly fit to the hole. This will tightly fit the hole, and it is economical in material and installation. Next we have high strength friction grip bolts. So these we use when bearing type bolt slips under shear. These have high strength, close to 8G or 10K grade, free tension against the plates to be bolted together so that contact pressure develop between the plates being joined. Prevents the relative slip when extra shear is applied. It will prevent the relative slip of the members when the extra shear is applied to it, then they have a higher shear resistance. Then we'll see the advantages of bolting, the bolted connections. Advantages of bolted connections. First one is the bolting operation is very silent. As we see, if we are going for riveting, then uh, after putting the rivet in the hole, we'll have to hammer it. So it will create so much of noise. Again, if we see for welded connections, the shock process, electric shock process will create noise. So bolting process, that operation is very silent. It won't create any noise. Then bolting is cold process, hence there is no risk of fire. As we can see in electric weldings, we have a risk of fire. Any type of welding will have a risk of fire, whether it is electric welding or gas welding. Then bolting operation is more quicker than riveting. In riveting, we have more chances of getting unequal heads. So again, we have to remove it and put another rivet. So bolting, while using bolted connections, we don't have such kind of problem. So it is actually quicker than any of the connections, and it requires very less manpower in making the connection. Coming to disadvantages, if it is subjected to vibratory loads, then it can get loosened. So again, we need to daily surveillance on it. We need to primary again and again we need to check the connections. As structure will vibrate, this there are chances of loosening the bolts. Then unfinished bolts have lesser strength because of non-uniform diameter. So these are the two advantages of using bolted connections. Then again, next type of connection we'll see according to the type of internal connections. In this we have shear connection. Then next one is movement connections. First one we'll see shear, semi-rigid or simple connection. Shear connection comes under simple connections. So it allows the beam end to rotate without a significant restraint. It transfers the shear out of beam. Most common types we have double clip and then shear end plates, then fin plates. For shear connection we will use these three types: double clip, shear end plates and fin plates. Secondly, we have this movement connections. So these are designed to resist both movement and shear. Shear connection won't resist movement, but movement connections will resist both movement and shear. These are often referred as rigid or fully restrained connections. We can call the movement connections as rigid or fully restrained connections also. So this will provide full continuity between the connected members. As we can see in the figure, the member looks like it is continuous. There is no gap or the connection gap in between them. It seems like it is continuous. So if you go for movement connections, then we'll have continuity between the connecting members. These are designed to carry full factored movements. Whatever the movement we are calculating and whatever the movement coming on the members, so it is designed to carry that full factored movements. Then building has to resist the effect of lateral force such as wind and earthquake. That is why we go for movement connections. Then next we have according to the type of structural element. In this we have single plate connections, double wave angle connection, single plate angle connection, double wave angle connection, top and seated angle connections, and seated beam connections. So one by one we will see all these four. So first one is single plate connection. In this we'll use a single plate to connect two different structural members. So this process is very simple, and this we carried out under two steps. So this is a basically two-step process. First one is a plate is welded to secondary section. It may be a beam. Then we will use a plate section. A plate is used to connect one member to the other member. Then what else we can use in it? We can use an angle which is welded to primary section, which may be a column or beam. Then again single shear plate welded to secondary. So for this single plate angle connections, we can use plate or angle to connect two different members such as beam or column. As we can see in the figure, here a plate is used to connect these two I sections. And this can be connected through bolt or weld. Then we have double web angle connection. So in this we will have two webs, two different members, and that will connect through an angle. So two angles we'll use in this, that is why we'll call it as double web angle connection. So two angles welded or shop bolted to the web of secondary beam. There is difference between shop weld and side weld, shop bolt and side bolt. The shop bolt will have more efficiency, it is more finished than a side bolt. Again we have two types in weldings, shop weld and side weld. Shop weld will be more smoother than the side weld. Obviously it will give us more strength than side weld. So here two angles are welded or shop bolted to the web of secondary beam. Then after erection the angles are bolted or side welded to the primary member. As we can see in the figure, this one is our primary member and this one is going as secondary member, and these are connected through this angle. So we'll have this angle at this side, again here, this side and that side. So it is completely connected through this angle members. Here we can see it is bolted. So four bolts on one member, then 4 bolts here on second member. And this one will be more stable than the single single plate angle connection. Then next we have top and seated angle connections. So these generally used in case of movement connections. Double angle and single angle we can generally use for shear, and this top and seated angle connections will generally in case of movement will use this. So two angles are provided at the top and bottom of the beam to resist movements. Generally these are used for lesser movement where heavy loads are not acting. So top and seated connection we'll use where we have very less movements. Then next we have seated beam connections. So in seated beam connections, these are generally used in case of shear connections. So a seating angle is at the bottom of the secondary beam, which can be shop welded to primary member. Then the seating angle resists the vertical shear coming from the beam. Whatever vertical shear is coming from the beam, that is to be transferred to the column. So the seated angle resists that vertical shear. Then according to the types of members joining, we have these 4 types of connections, which is this type we are considering to understand the connections better. So connection can be beam to beam connection, that is one. If we need the continuity in the beam, then we'll connect two beams, so it will be beam to beam connection. If we have longer spans, then we'll go for the beam to beam connections. Then we have column to column connections. If you have multi-story building or the height is little bit more, then we need to connect one column to the other column, that is column to column connection, that is also called as column splices. Then at every joint, every floor, will have beam to column connections that we can that we generally see in frame structures. To easily understand it, we can see the like frame structures, we have a beam to column connections also in steel structures. So those are beam to column connections. Then we will have column to base plate connection. As we all know, the load is getting transferred from beam to column, then column to the foundation, as in case of frame structures, RCC structures. So in case of steel structures also, the loads are getting transferred from beam to column, then column to the foundation. So in between the foundation and column, we'll have base plate. The base plate will carry all the loads from column and it will transfer the loads to the foundation. So those connections either mostly will go for bolted, as we need to transfer heavy loads from the column carries to transfer to the foundation. So usually we'll go for bolted connection. We don't generally use welded connections for it. So those connections are column to base plate connections. Thank you.